Go. Welcome to technical session number 36, 10:02 level technical session. We're going to talk about implementing hard drives, and we're going to get a little bit into the purpose and methods of hard drive partitioning. We're going to briefly get into and explain the purpose and methods of hard drive formatting. And we're going to talk about fun things like file allocation tables and different file systems you can use. And we're going to identify briefly some common hard drive problems and how to explain, how to maintain, and troubleshoot these issues as we go through. Behavior, skill, and mindset we want to keep in mind during this technical session is teamwork. IT is a team sport. And you want to be a value-added member of your team. Understand that everybody on the team is not going to have the same skill sets, just like in our team here. Places where I'm weak, Rachel is strong. Places where Rachel is weak, DW is strong. You know, we have different strengths and weaknesses throughout this field. We also have different interests. You know, IT may be more, or excuse me, cybersecurity may be more of an interest to you, but networking may be more of an interest to your teammates, whereby you may know more in these subjects, even at a theoretical level, than your teammates. So it also brings a value-added aspect to the workplace. And persistence is the other one. In any sort of troubleshooting or problem-solving endeavor, persistence plays a huge role. Just the very element of grit in us is a big factor on whether or not we will succeed or fail in whatever goals we set for ourselves. You know, the very fact that you guys are still showing up every day, we're a little over a month in, shows a lot of persistence, because this isn't easy. So, but you guys keep fighting for that goal. You know what you want, and you keep moving every day, step by step, closer towards those goals. All right, brief overview, hardware partitioning. Let's see here, Kevin, can you read for us, please?
Sure thing. You can hear me?
Yes, sir.
Okay. Hard drive partitioning overview. Partitioning is the process of electronically subdividing the physical hard drive into smaller units called partitions. A hard drive must have at least one partition. Partitions allow to use multiple OS in the same hard drive, one per partition. Windows supports 3 partitioning methods. 1, master boot record. 2, Windows proprietary dynamic partitioning scheme. That's a mouthful. 3, GUID partitioning table.
Excellent, thank you. So I know how much you love acronyms in this class. You know, like we love talking about, you know, MAC addresses and SMIME and MIMO and all these fun little acronyms and stuff like that. So in order to kind of take it up a notch here, we have an acronym within an acronym. So you have the GUID partitioning table, the GPT, and GUID stands for Globally Unique Identifier. We'll get into that a little bit later, but it is quite literally an acronym within an acronym. And all this is essentially your hard drive is like a piece of pie, and you're breaking it up into smaller and smaller chunks depending on your needs. And that's what we're doing. So master boot record, the main one we are talking about here. Jamari, can you read for us, please, sir?
Hard drives using MBR partitioning scheme have a tiny bit of data in its first sector that is also called master boot record. Or MBR also contains the partition table, which describes the number and the size of partitions. On the disk, MBR partition tables support up to 4 partitions. When the PC boots up, BIOS look at the first sector of the hard drive for instructions in the partition table to determine which partition contains the active operating system.
Thank you. So MBR basically does what it says it does. It's the master boot record. If you have multiple partitions, this is where those records would be kept to tell the operating system where to look for the operating system. So you would say, yes, we want to look at the hard drive. You go to the hard drive. So when you have a BIOS, you have your boot order. Your boot order is hard drive. It goes to the hard drive. Hard drive looks at the master boot record and says, yep, I keep the operating system for this in partition 2. And if you wanted to set up multi-boot, depending on which one you would select, say if you had Windows, Mac, and Linux all on the same system, depending on which one you would select, that master boot record would point the system to the correct partition to boot up the appropriate operating system you're looking for. So pretty straightforward, thankfully. Primary partitions under the master boot record. Tomas, can you read for us, please?
MBR partition tables support 2 types of partitions, primary and extended. Primary partitions support bootable OS, while extended partitions are not bootable. A single MBR disk may have up to 4 primary partitions or up to 3 primary partitions and 1 extended partition. Primary partitions are usually assigned 1 letter starting with C. Each primary partition is a single drive that is used special setting stored in the partition table called active and determined an active partition. Grub Boot Manager is also used to control multi-boot setups with 1 Linux OS.
There you go. So you have primary and extended, and this is basically how they break it up. It's, again, pretty straightforward, thankfully. Any questions so far? Always the first drive of your primary partition is going to be the letter C. But you could go all the way up to Z if you wish. All right.
So isn't an extended partition an active partition?
Is an extended one an active one?
Yeah,
How do you mean?
I mean, it shows there the primary partitions are active, right?
Mm-hmm.
But up there it says that it's extended partitions. I'm not sure. Oh, it kind of confuses me. I'll probably come clear later.
No problem. So I mean, active in the sense that it is being used on the table now. So yes, I would say yes, they are. All right. So extended partitions. So those can contain multiple logical drives, each of which can get a drive letter. So that may be so it looks like a primary partition, but you can't boot from it. So it's a different partition or whatever, but you can't host an operating system upon it. But it may be a separate file structure or place where you would store things. So it'd be D drive or E drive or F drive, but you wouldn't be booting an operating system from it. So primary would be one that you would boot from. So you may partition your drive into multiple drives, but say if you were setting up a share file system, like, you know, I want to share part of a drive with generation. I may create an F partition and say, this is where my share folders are for generation. But then I would create a G partition, and that would be the files I would share for my household. And so I would only grant the generation group access to F drive. But that's not where my operating system is. It's just a file system. Does that make sense? All right. All right, dynamic disks. Bernard, can you please read for us, sir?
Dynamic disk storage partitioning or dynamic disk create structure called volumes. The number of volumes that can be created in a hard drive is not restricted. Dynamic disk always implements RAID, span, stripe, and mirror over multiple drives. Only low-end versions of Windows 7 don't support dynamic disk.
There we go. So you can break up your hard drive into multiple chunks, these extended partitions, or you can add other drives to it and set up a RAID scenario within your dynamic disk setup. But again, it only works on Windows 7. I think it's like professional, enterprise, and then up into 8, 10, and now 11. So not all RAID arrays are allowed. So can someone tell me or remind me briefly, because I've slept since I talked about this, what's the difference between spanning between two drives and striping two drives? We got a call for a volunteer.
Striping, you're splitting the data up, while spanning, you're kind of like copying data over.
Knocking on the right door, kind of close. We are close. So yes, this does have to do with RAID a little bit. So striping, yeah, we split up the data. We'll put bit 1 in drive 1, bit 2 in drive 2, bit 3 in drive 1, bit 4 in drive 2. So we're splitting that data up and spreading it across two drives. So that's striping. What's spanning?
Is spanning like cloning?
Not quite like cloning. Melody talked about mirroring, and that's more of a RAID 2, or excuse me, a RAID 1 function. Spanning works a little bit differently.
Is it similar to Stripe? Because it sounds, what the name sounds like is it sounds like it's like the data is spanned across all drives.
Yes, starting to get there. So what it is it's operating like it's a single drive. So striping is splitting the data across two, which is increasing your speed, but spanning is just like essentially taking two drives that are operating as one. So as one fills up, then it kind of spills over into the other, spanning across two drives, operating like they're one. But what is on one isn't necessarily on two. And if you lost one of those drives, you wouldn't lose all your data, only the data that was on that original drive. Because it's not splitting the data at a bit level. It's just like, like you have 2 cups of water. As one cup starts to fill up and overflow, it pours into the other cup.
So like let's say like you're downloading like a video game, and like you have some space still on one drive, it'll fill up that remaining space and then go over into the next drive.
Yes.
Okay.
So if you needed if you only had 3 gigs left and you spanned it to another drive and you needed 10 gigs for the game or whatever, we put 3 in that one and then start filling up the other drive. All right. It would still look as if it was on a single drive.
Yep. All right.
Well, I thought that was like the same thing as striping. You think like striping that?
No, striping would be, no matter what it is, it would split the data, essentially in half if you had 2 drives. And it was at a bit level. So it would take 1 bit, put it in one bit, put it in the other, 1 bit, put it in one bit, put it in the other, until the data is basically broken up into 2 chunks. And it's maximizing the amount of speed that the system can read and write from each drive.
So in the sense of the example Kevin was using with the game, so you could only put that game into one drive. It wouldn't be able to split that game into like both drives.
Well, it's not. Well, it would be splitting it into both drives. Like if it couldn't fit on one, it would spill over into the other drive, and that would be okay because those two drives would be looked at as a singular drive by the system.
Okay.
So you have drive A and drive B. You have 5 gigs on drive A, 3 gigs on drive B, and you span them and then just call them together drive E. So A and B together make drive E.
Okay.
And so it just writes to where the availability is, and then if it spills over into the other drive, that's fine.
Yeah, no, I understand that part, but I was saying that for like the striping part, in what way would that work if you were trying to use striping for that? Like,
Well,
would it just like
in striping, I'm splitting the data evenly across the two. In this, I'm essentially, like, you could think of it almost like I'm filling up one drive, and then once that drive's full, then I'm starting to add that information to the second drive, but the computer still sees it as a singular drive.
Okay.
But say I had 10 files, 7 on one drive and 3 on the other, and the drive with 3 fails, I would still have the 7 files. Whereas striping, I took the same 10 files and I split them across the two. One drive fails and I've lost both. I've lost everything. But
okay.
But I'm able to, in the RAID where I've split it, I'm able to read and write that data at a much faster pace.
Okay. I was misunderstanding what striping was. Okay. So you lose everything. Okay, thank you.
Yeah, and that's striping and spanning to give you kind of the difference between the two. All right, so getting into the GUID, or Global Unique Identifier Partition Table, or GPT. Yuki, can you please read for us?
Yes, GUID partition table. The Global Unique Identifier Partition Table, GPT scheme is very similar to MBR, but it improves MBR scheme's limitations. Unlimited number of partitions, windows limited to 128, partitions larger than MBR limit of 2.2 terabytes. GPT is arranged by LBA instead of sectors. LBA 0 is the protective MBR, a recreation of the master boot record from MBR drive, so disk utilities know it is a GPT drive and don't mistakenly overwrite any partition data. GPT drives use a GPT header and partition entry array. Both are located at the beginning and end of the drive, so there is a protected backup copy. The partitions on a GPT drive go between the primary and backup headers and arrays.
Good. So previously we couldn't write in the MBR, we couldn't write partitions larger than 2.2 terabytes, which is starting to become problematic with the size of hard drives we're using, right? So if you have a 10 terabyte hard drive and you can only have 2 terabyte partitions, it means no matter what, you've got to break up your drive into multiple sections. Versus using a GUID or GPT, you're able to bypass that. And also the other situation where we could only do 3 primary partitions. Here we can have up to 128 now. So we can break up and fragment that hard drive as much as we see fit. Questions, comments? All right. GPT conditions. Gali, can you read for us, please?
GPT GPT condition Windows. Windows can only boot from GPT on UEFI based computers running 64-bit version of Windows 10, 8, 8.1, 8.7, Vista, and corresponding server versions. All versions of Windows 10, 8.1, 8, and 7 can read GPT drives and use them for data. They just can't boot from them without UEFI motherboard.
What would be the alternate to the UEFI? What is that? You know, what would be our
BIOS.
choice? There we go, BIOS.
Other operation systems, other operating systems can also use GPT. Linux has built-in support for GPT, even with older BIOS or
Okay, but that meant BIOS.
Oh, that's like, oh, that was supposed to be BIOS?
Possibly. I think it's a typo.
Oh, okay. I was gonna say, what is a BIOS? Okay.
Typo, I believe.
Or UEFI firmware. Apple Intel Macs no longer use Apple APT, Apple Partition Table scheme, and use GPT instead.
There we go. So if you want to use GPT, you got to be upgraded to UEFI. You cannot use old school BIOS. And you need to use a 64-bit version. 32s will not suffice. All right, when do we partition? Rahel, can you please read for us?
When to partition. The two common situations that require partitioning are: 1, when installing an OS on a new system, or 2, when adding a new drive to an existing system. When installing a new OS, the installation program asks how to partition the drive. When adding a new hard drive to an existing system, every OS has a built-in tool to help partition it. Windows offers different tools for partitioning hard drives. CLI program called fdisk is the oldest one. Modern versions are disk management, located under computer management in administrative tools.
Beautiful, thank you. So underneath our modern tools, we have disk management, which is under our computer management administrative tools. Looks something like this. It's pretty nice, friendly. I'm sure you guys have done a lab on this. If not, don't worry. There are some labs and test out we will be doing. But I believe that we've already reached those when we did drives in general. And CLI, what do they mean by CLI? Who remembers what that is?
The command line interface.
Here we go, command line interface, CLI. That's that screen that looks like this. So we can either do it in disk management, which is a nice little graphical user interface like this, or we could use the command line fdisk and operate it like this if we so choose. And I believe we have both labs set up where you could do them either way. If not, I am fairly certain Coursera does it as well, if I remember correctly. Well, Coursera will also ask you to partition in Linux. So that lab can be tricky. You have to pay attention to that one. There's a lot of let's just say that's like the motherboard lab and test out. It's that, but for Linux. So it's usually the one that people get hung up on. Questions so far? Pretty straightforward, right? Partitioning is just breaking up that, your disk drives. It's kind of like a pie. We're breaking it up into smaller chunks to do what we need it to do. And then there's a couple different flavors that we can use to do that. All right. Formatting. So who here prior to this class thought that formatting erased a hard drive? None of y'all thought that? Y'all thought that like once you format it, everything's still there?
I did. I always have to erase myself.
Okay. So formatting does not erase what's on your hard drive. What it does is essentially is just creating a file system. How do you want files and things to be located on your hard drive itself? And it makes a root directory in that file system. Yes, golly.
I was gonna say, yeah, I always thought that because it say that literally right before you format anything, it'll say that if you format this, everything in your hard drive would be erased. So it's not like, so that's not true.
No, it is not true.
Oh,
So what it's doing is like, it's basically saying that these sectors can now be overwritten. So instead of saying that these spots on your hard drive are full, it's saying these are essentially now empty slots that you can put data in if you wish. But any computer tech who knows what they're doing can recover that data from those drives if they're just simply formatted, because the data hasn't been overwritten yet. It's still there. What it's done is it's erased the tables that show you how the data is to be assembled. So, but the data is still there. So please, from a security standpoint, do not think that formatting a disk means you're erasing the data. All right. So when you do format, you're setting up a file system and how all data is going to be placed on your drive from that point forward. So every version of Windows comes with this built-in utility, which you can create partitions and manage your file systems called disk management. That's where you can do a lot of the stuff in Windows. There are different file systems we can use, and some versions of it are FAT16, FAT32, FAT64, otherwise known as exFAT, and NTFS. Those are the main file systems that are used by Windows for the most part. You're sitting there going, what the heck does that mean? Glad you asked. All right. So, FAT16. This is essentially the base. This is the lowest level file system. And FAT16, when they're talking about that, FAT stands for File Allocation Table. That is how data is going to be entered into this system. And it's stored into chunks on the hard drive called sectors. Now, for a FAT30 or a FAT16, every sector is 512 bytes of data. Here's the problem. If I was going to install a program on here and say that program was 515 bytes of data, I've now gone into a second sector. As this needs to be, each sector needs to be associated with a particular file. You can't split up sectors for multiple files. All the rest of that sector data is wasted. So we want to try to be as efficient with this as we can, obviously. So once the operating system stores the file, it must remember which sectors hold the file and how to put this data back together so that it can be utilized. Because of this, we utilize what's called a file allocation table, which tells us how the data is put in, how do we use it, excuse me, excuse me, and how it's to be reassembled. So a file allocation table is essentially an indexing system for all the data on the hard drive. It uses essentially a 2-column spreadsheet where the left column gives us the sector in hexadecimal format and lets us know what sector of the hard drive this data is stored upon. And then the, I think the right column contains the information on the sectors. So it tells us what sector we need to look at next for this data. Also, it'll mark all zeros if the sector is empty and availability written to. And if it's a bad sector that cannot hold data, it'll write in FFF7. In total, with the hexadecimal bits, we have a total of 64,000 sectors that can be tracked. So you're sitting there thinking, what the heck does this look like? We will get into that. Don't worry. So the 16-bit is limited to that 64,000 clusters and 512 bytes per sector, or a total of 32 megabytes. Doesn't seem like a lot, but it was back in the day. Then this led to the improvement of the FAT16 called clustering, which enables us to enable partitions larger than 32 megabytes. So clustering allows us to combine contiguous sectors or sectors that go together. You know, like if we're talking about Microsoft Word, all the files or the clusters that are meant for Microsoft Word would be considered contiguous sectors, so they belong together. And we're able to treat those as a single unit, and those units are called clusters. You know, fortunately, the size of each cluster is not fixed, and the larger the partitions you have, the more sectors per cluster. And FAT16 is the smallest, and it can support clusters up to 2 gigabytes. Again, does not sound like much, but back in the 90s, it was, you know, like 96, 97, having a 1 gig hard drive was huge. Nowadays, you can't do anything with that. Back then, that was a lot of space. So we quickly kind of outgrew this. But again, what does it look like when we're storing data in this type of scenario? Well, here's an example of a FAT16 allocation table. So remember when we said if it's got 4 zeros, it means what?
It's empty.
It's empty and it's good to be written to, right?
Yeah.
If it has FFF7, what does that mean?
It's
Can't
bad.
write to it.
Bad sector, cannot write to it, right? So we see here all of these sectors are good. We have 1 bad sector we cannot write to. So when we're installing a file on here, get my annotator out. So when we're installing a file, the first one we start to install this file on is at 3ABB. And we go to the next one, or our status, and it says 3ABC. And what that tells us is to look for the next cluster that's going to have our information in it. So we go to 3ABC. That's where our next piece of information is for this file. And then if we look, 3ABD is bad, right? We cannot write to it. So when we look at our status, it says 3ABE, which skips over that sector, gives us 3ABE. And then when we see FFFF, that means that is the end of that file. It doesn't need to look for anything else. So it tells us where the next sector is that we need to go looking for our data up until the very end. And then it gives us this 4F to tell us that is where we terminate. That's the end of the file. So here's a real straightforward one. It's like 3ABF is the beginning. It says 3ACO. We go down to 3ACO right here. Tells us 3ACI or 1. We go down to 3AC1 right here. Beautiful. And then we get FFFF telling us that is the end of the file. And then down here we have 4 sectors that are wide open, ready to be written to. Why is this important? Well, what happens when we write and delete things from drives repeatedly? Over time, the drives become what's called fragmented. So as we can see here, so say you deleted a little bit of a file and you needed to write a new file in, you have 3ABB, goes next 3ABC, next file, 3ABE. It jumps over this because of that bad sector right here. So we have 3ABE, 3AC4. Uh-oh, there's another file here. This chunk right here is another file, but we still need to write. So we have to skip over that file and continue writing. So you see how information writing to the drives is you delete and add and delete and add over time. The data starts to become kind of fragmented. It's all over the place because you're having to find those little spaces where things have been deleted. When we reformat a hard drive, it takes all these files that are kind of scattered around and puts them together so that we don't have to jump around looking for all the little pieces of the file. They're all clustered together in contiguous sections. Is this making sense? Am I making it worse? JR is nodding his head yes. (50-50), all right. So yes, Golly.
So when they go back to being reformatted, are they still like fragmented? Like they just like got reformatted in the corner, like somewhere, just like they are like right now, or they like actually get put in order and stuff like that?
Well, no, when I defragment, not when I format, when I defragment, so say this is, just to kind of make it easier, this is section 1, 2, 3, 4, 5, and 6, and 7 of one file. And this is section A, B, C, D, E of another file. So we have 2 different files. A, B, C, D, E was here first. And when I was trying to write my 1 through 7, I had 4 spots up here and 3 spots down here available. So I had to skip over that file in order to write the rest of my file. Does that make a little more sense?
Yeah, a little bit.
And so the first section is the spot that you are on the drive. The status, what this is telling you is where I go next to look for my data. So in order to fill this file, this 1 through 7, I'm at 3ABB. So I look at my status and it says 3ABC, which is the very next cluster. So I go there. There's my other chunk of data. I check my status on that data and it says 3ABE. Well, that's not the next one because that's a bad sector. So I skip over it and I go 3ABE. So from here to here. There's my next chunk of data. I check its status and it says 3AC4, which is all the way down here. And then on and on until I hit FFFF, which is the end of that file. So it's basically putting these files in little chunks but it's fitting those chunks in wherever it can. You know, like if you have a junk drawer in the house, you can't put all the stuff you want in like one little corner. You kind of got to shove it in there wherever it'll fit. And then, you know, hopefully be able to still close that drawer. Is this getting a little better? Do you have to be an expert on this? No, you do not. Big takeaways is just understand your status tells you the next sector where you go to find data. 4 zeros in a file allocation table means it is open for business. FFF7, bad sector, cannot write. And then 4F is the end of a file. So those are the main takeaways you need.
So like before, when you said if an expert technician know what they're doing, they'll be able to retrieve a file. That's how you would have to go in and look for the file, or
well, here is how formatting works. When I format a hard drive, say, here is my file allocation, right? When I format the drive, I basically erase all this data so that it looks like this. The data is still there, but I have written that it is 0000 ready to be written to. That's all I've done. I've changed the allocation table to say it is okay to write here. Until we write to it, the data is still there. So if you want to erase a hard drive so it is not recoverable, you have to repeatedly overwrite a drive multiple times, so that forensically it is very difficult, if not impossible, to come back and look and see what was written on it before. That's how you erase a drive. All you've done here is erase the map. When you format, you're erasing the map to recreate or put that data back together. And so forensically, you can go back and recreate it yourself. There's programs and algorithms that help you to do this.
Got it.
Please ask questions if you don't understand. Because I guarantee you, if you have a question, somebody else probably has the same one. Is this making any sense? Getting a couple slight nods, getting a, you know, kind of like, eh. Again, you don't need to be an expert on this. It's just kind of understanding that this is how the file systems are set up inside the computer. Yes, Rebecca.
So when we format the status, where do we get the three ABC numbers?
That's the name of those sectors. So it would start at like 0000, 0001, 0002, 0003, and go all the way up through hexadecimal numbers until you get all the way to FFFF, which is the end. So that's just the name of the sector on the drive. So that tells you in that location, that's where this stuff is. It's like its address.
So the FF7 will be an error, so we'll jump it to the next level.
Correct. It would go from, say, 3ABC, it would skip over it and go to 3ABE. Because it knows it cannot write here because this is a bad sector.
No.
Make sense?
Yes, thank you.
Mm-hmm. Okay.
Can you repair bad sectors?
Sometimes. Sometimes they'll give you the option that says, would you like to attempt to repair bad sectors? And so it will give it a chance and see if it can, but if it is, you know, still volatile or not trusted, then it'll just say no, it'll quarantine it and not allow you to write to it. So you may see that sometimes when you're you're defragmenting your hard drive, it may say attempting to repair bad sectors or something like that as it's shuffling data around. All right. That was the worst part of this technical session. It's easier from now on. That was the meat of it. So now we can move into Fat32, which is an upgraded version of the Fat64 allocation tables. This one uses 32 bits to describe each cluster. And it supports partitions up to 2 terabytes. How much did a Fat16 go up to?
Gigabytes, 2 gigabytes.
2 gigabytes. All right, so we've gone up by, you know, essentially 1,000% almost. So we now have 2 terabyte partitions allowed on a Fat32. It allows you to use much more efficient use of disk space without the need to make multiple small partitions. Thank goodness. However, it still needs a heavy amount of defragmentation like the Fat16s did. So this is still used pretty readily today, though not typically as, you know, on hard drives that we would use for our computers, not on our internal hard drives, not for operating systems or what have you. This is typically used on jump drives, flash drives, your little USB sticks. That's typically where you would see Fat32 used today. One of the more common places you will find it. Questions so far? All right. Next, NTFS, or New Technology File System. Uses clusters and file allocation tables, but far more complex than Fat16 or Fat32 did. It also adds a bunch of fun improvements, such as redundancy, security, compression, encryption, disk quotas, and cluster sizing. Because of all these fun features, it is the most common used currently. However, external hard drives and flash drives do not use it because of the security and encryption can make things difficult when moving between 2 systems. What piece of hardware is on our motherboard that kind of works and aids in the encryption process that we would use, like it works in conjunction with something like BitLocker? So what piece of firmware is attached to the motherboard that helps this happen? Everybody wants. There you go, Greg. TPM. Somebody other than Greg, what does that stand for? I think you got it, JR. No? Okay. Thought I saw you mouth it right. You want to take on it? I'll give you the first letter, trusted.
Trusted platform module.
Perfect. Trusted platform module. This is a piece of firmware that is attached to our motherboard that works in conjunction with BitLocker to help encrypt and decrypt the entire drive. This is utilized through the NTFS file system. So NTFS utilizes a enhanced file allocation table called the MFT, or master file table, or filled table, excuse me. And the partitions keep a copy of the MFT in the middle of the disk to reduce the chance of losing it and its copy. Now, on a security level, it views individual files and folders as objects. You do need to remember that. NTFS views individual files and folders as objects and provides security to those through the ACL. Remember talking about that with firewall, the access control list. Use individual files and folders as objects and uses ACL, or access control list, to provide security to those objects. Meaning it will not allow them to pass through the firewall without special permissions, or only to approved people. Compression, such a wonderful tool. It allows us to compress individual files and folders to save space on our hard drive. Only downfall of compression is it slows things down a lot. So we would compress files we weren't necessarily going to use on a regular basis and then decompress them as we use them. And if we're doing this on a regular basis, it really slows things down. If we have to decompress something every time we use it, then compress it every time we save it again, because it's using mathematical algorithms to kind of, shrink things down in a logical manner so that we can unpack them later. All right, encryption. So the encryption level that we use for the NTFS is called the EFS, or Encryption File System. Remember we talked about BitLocker encrypts the entire drive, which is nice because, we're able to protect all of our data. But EFS allows us to do that to individual files and folders rather than just the entire drive. Because again, encryption, much like compression, has a tendency to slow things down. So here we can pick and choose what we want to encrypt. I don't really need to encrypt my high scores on Candy Crush. Maybe from my boss, if I'm doing that at the office. But my research and development, if I'm developing applications, the code, all that stuff that I'm writing may need to be encrypted. So I would use the EFS, Encryption File System, to encrypt individual files or folders. Disk quotas. This is a nice thing. So if we're setting up shared drives or whatnot, I can set up individual quotas. Say, Rachel, since she's nice, I will give her, 500 gigs of space on the hard drive. DW, less nice, I'll give them 500 megabytes, So I can set disk quotas for individual users, saying you cannot exceed this amount of space on each individual drive. Because if you don't do this, there are people that will save every single document, file, folder, web page, or whatever that they come across, just because they may want to read it later. If you don't think you're one of those people, show me what your watch list looks like on Netflix. How many of you click on, yeah, add to my watch list, add to my watch list, add to my watch list? A year goes by and you have like 1,000 things on there and you haven't watched any of them. All right. Cluster sizes. NTFS is nice. It allows us to adjust the size of the cluster. So by default, it can support partitions up to 16 terabytes, which is pretty awesome. It's a pretty good, robust size, but you know, we'll probably say in about 10 years, like, man, my hard drive only has 20 terabytes, you know, at the rate we're increasing in data usage. So it allowed 16 on a dynamic disk, but only 2 on a basic disk. All right, finally, FAT64. So we said FAT32 only supports drives up to 2 terabytes, typically seen on USB sticks. And individual files can only be up to 4 gigabytes. So an individual file can only be that big. New FAT system, which is called FAT64 or exFAT, can support files up to 16 exabytes and a theoretical partition limit of 64 zettabytes. Anybody want to consult their coworker Google and tell me how many gigabytes are in 16 exabytes? Nobody? See, now I'm curious.
It is 10 to the 18th bytes, 1000 to the 6th bytes, which is a lot of zeros.
It's a lot of zeros. So 1 billion gigabytes. I can't do a good Dr. Evil impersonation, so I'm not even going to try. So yeah, 1 billion gigabytes for a file size. And zettabytes is probably like like 3, you know, like 1 undecillion gigabytes or something like that, some obnoxious number like that. It's typically used by large capacity removable storage. I use it on my removable hard drive, which is 16 terabyte hard drives, just because it's easier. And large capacity USBs, memory cards, and things like that. Again, remember, USB drives and external hard drives do not use NTFS because of the encryption and security features can be very problematic. Questions, comments, concerns? All right. So we can't let Windows have all the fun. So other file systems that can be utilized, we have the ext4, 2, and 3 in Linux. Don't worry, you'll get your practice with those very soon. And Linux is able to read and write to NTFS, FAT32, FAT64, and then the HTF plus for Mac. And ext4 not compatible with Windows, while ext3 is. So kind of moving apart. They support ext4 supports files up to 1 exabyte, individual files up to 16 terabytes, and then it can contain up to 64,000 subdirectories. This is a lot. And it gets some reliability and performance boosts over ext3. So basically, if you see ext2, 3, or 4, please associate that with Linux. That is the big takeaway from this with regards to A+. And I know you're sitting there thinking like, gosh, that can't be enough file tables. Are there more? Yes, there are. So we have, it seems like it's 2 on the nose. And I guarantee you will see a question on this. What is the file system that is used on a CD-ROM? CD file system. It seems, like I said, it seems like it's 2 on the nose, kind of like Windows Update. But that's exactly what it is. CD file system, CDFS. And then the one for DVD is UDF, which is Universal Disk Format, UDF. I would remember those because I guarantee you'll see a question on them and it's a gimme. Then I believe lastly, we have our NFS, which is our network file system. This is a distributed file protocol originally brought to us by the makers of Oracle, Sun Microsystems. And this makes us, makes it much easier for us to access file systems on the network. And we can access them as easily as if they were on our computer themselves. And even if the host system is of a different OS, you can still share the files. A lot of this stuff is happening behind the scenes. We never really see it. It's all automatically. But when we are formatting our file systems, these things become extremely important, especially if you're switching between like a Mac and a Windows machine. Some formatting systems for a Mac cannot be seen by Windows, and Windows will automatically just try to format that hard drive and erase all the data you have. So you have to be careful which file systems you are using depending on how you're moving your data around. Questions?
What did I miss?
We had a lot of the answers to 1001. I'm sorry you missed it. It was great.
Damn it! I figured it would be now. All right, but yeah, so far so good.
All right. So quick format versus full format. As we talked about earlier, formatting does not erase the hard drive. It just essentially removes the map. There's 2 different types of formatting you can do. There is the quick format, which essentially just resets the map so that you can write data to it. And then you have the full format, which looks for bad sectors and kind of tests the drive to make sure everything's okay. So quick format, nice and easy, pretty quick. Full format takes a little bit more time because you're gonna have to check for bad sectors. In the disk management tool, here's where it looks like. If you're creating a new volume, you can select which file allocation table or what file system you want to use. So you can select it in here, and depending on the size of your volume and what you're going to be using it for, this is something you definitely want to pay attention to. Don't worry, there is lab practice for it. This process, I would pay very special attention to for 1002. I remember having a performance-based question and a bunch of questions during the test that revolved specifically around this process of creating new files or creating new, brain went blank. New sections on the drive or volumes. There we go, creating new volumes. So pay close attention to it. Definitely practice it a few times in test outs. Get comfortable with it because you likely will see questions on it. If not, a performance-based question exactly like it. Yes, Golly.
2 questions. First question, for the tests, for the performance-based question in the test, like, is there like, I know they're probably gonna change it every time, but is there like some that like most always go toward? I mean, just like you say, this one was something they go to, or is there like some, some of them they're usually almost 90%, they're like always 1 or 2 of those, like.
Well, there's
like
a pool that
predators,
there's a pool of ones that they pull from. So there's certain ones we can say you're likely to see it.
Okay.
Because there was ones that I had that Rachel and DW did not have. There was a couple that they had that I didn't have. So they are updating them over time. And some of them you see, some of them you don't. So we'll just say like likely. There's ones that you do see all the time. Rachel, did you get one about setting up a different volume in 1002?
Absolutely.
Okay.
Absolutely. Just it actually looked just like this.
There you go.
So, yeah, because I know, like, I know there's a lot of them, but some of them are so easy. I'm like, they're probably not gonna put those. They're probably always gonna gear toward, the most, like not so hard, but like, common one that's like this. But okay. And second question was about this test out. Is there like somewhere you go that you can just do all the labs only without like have to go through like the whole chapter and stuff? I mean, when you're done with everything, like,
Well, yeah, you can go and you can jump straight into the labs through the chapters.
So, but okay, I gotta figure out how to do that. Okay.
I can show you how to do it later.
Okay, no problem. Thank you.
As soon as we're done here, I'll show you how to do it. All right, any other questions, comments? All right. Troubleshooting implementation of a partition. Failure to partition or making the wrong size. Open up your disk management. Redo the partition correctly. If the problem is the secondary drive itself, that would be the way to go. If it's the operating system, try to use command line and go to fdisk and see if you can set up the partitions there rather than trying to do it in the disk management application. So try it in both locations first. But make sure you're setting it up the correct size and you have the available space to set up that particular drive. It should give you an error if you're trying to get a partition that's too big and you don't have enough available space. But always double check and make sure you're setting it up the correct size. All right. Failure to format. So accessing the drive in Windows results in drive is not accessible, error, or invalid media type error. This is a formatting error. Unfortunately, this can make it unreadable going forward, and corrupted files can do this. You can try reformatting it from that point and see if that helps. but that would be your first course of action. Like, all right, physical problems to your hard drives. This is mostly due to, or mostly with regards to mechanical hard drives, not solid state drives. So if you start hearing a continuous high-pitched squeal, that is fun grooves being cut into the platter on your hard drives. And that is the sound of your data going away. Loud clicking noises, short pause, then another series of clicking, continuous grinding or rumbling or other bad signs. If you're running into this, your hard drive is dying or about to die, you need to replace and back up your data as soon as humanly possible. I mean, if you start hearing these sounds, that becomes top priority. It's not, oh, I'll do it this weekend. Oh, I'll do it tomorrow. No, number one priority is backing up your data so that you can salvage as much as possible. If the one with the operating system on it dies, your system's going to lock up and it'll give you a no boot device present. And then if it's a secondary drive, it'll just stop showing up in your Windows Explorer. In that case, first, before you replace the entire drive, make sure you check your cables first. If you have multiple drives, try swapping, like if you say have 3 drives, you have your one with your operating system and the other 2, try swapping the cables and the other 2 and see if that fixes the problem. Make sure your connections are good, all that before you replace the drives, just to be double sure before we go start spending money and replacing hardware. Because cables do go bad from time to time, especially if they get jostled and bumped over time. And then there's always a case of chip creep over time as well, where they slowly kind of work their way out. Questions? Almost there. But we have a quiz first.
I got a question.
Yes.
So like a hard drive, I guess the drive in the laptop, like how long does like I guess the lifespan usually are? Like let's say you're not really using them, like utilizing them like that. Like, so
Mechanical drives with light use can last a very long time.
Right, okay.
You're talking years under light use. Under heavy use, you can burn up a drive in very short order. You can, do it in less than a year or two. My current one I have, which is a mechanical drive, it's currently about 7 years old.
Okay.
So I mean, it's working for a good while. So I know it's getting a little long in the tooth, which is why I keep multiple backups. Pause the recording. Any questions, comments, concerns, complaints, revelations? All right, we should now be able to explain the purpose and methods of hard drive partitioning, hard drive formatting. We should at least have an idea as to how a file allocation table works. So we know kind of how the files are being put into the drives and why we would need to do something like defragmenting as we are adding and deleting files over time. And we should also be able to identify some common problems with hard drives and explain how to maintain and troubleshoot these issues.